Okay guys, so welcome to this tutorial. Today we're going to be creating this liquid projectile simulation in Houdini. Let's get right into it. Okay, so what you're going to want to do first is drop down a geo node and dive into her, and then drop down a sphere node, then drop down a points from volume node, set particle separation to 0.05, drop down a null, drop down an attribute wrangle, type in the code at n, which is normal, equals 0,1,0, semicolon, command enter or control. Duplicate that node, connect it like that, and type in this node at v equals at capital N. Drop an attribute VOP node, and then dive in. Drop down a turbulent noise node, a multiply node, connect V of the geometry VOP into multiply input 1, connect the P of GeoVOP into the position of the turbulent noise, connect this noise to the input 2 of multiply, then this product multiply into V. Then right click on the turbulent, middle click, sorry, on VX/VOP, create input parameters, then come out, and now if you scroll down on this node, you can see all this. So I'm going to set my frequency to 6. The amplitude to 3. Then drop down a null node, and name it out source. Drop down a .net and dive in. Drop down a flip solver, then a flip object. Connect the first input of the flip object to the flip solver, then the flip solver to the output. On the flip object, set the input type to particle field, set the sup path here to be null out source. On flip object, the guides, go to particles, visualization, set it to particles, and if you play this out, it should just rise up like that. On the flip object, set the particle separation to 0.01, and then copy parameter, then come out and go to points from volume and paste relative reference here to point separation. Then drop down another attribute wrangle after the attribute VOP and write in then click on the spare parameter, scroll down, and then set this to 12. Make the .net visible and then give it a play. As you can see, we have like kind of like a particle explosion right now. But if you go into the flip object and set it to 0.1, then come to Geo, just give it a play, and this just makes it so we can just visualize it easier. So go to attribute VOP and then mess around. So like, I don't turn the roughness up and see what happens. Let me just turn the clock thing off. I'm gonna turn up the say 0.05. Well, that seems pretty good, but like you can just adjust the attribute VOP settings to however you like. But we're gonna move on to the next part, which is dropping down a DOP import field. Bring in the DOP network here. Bring in the flip object. Scroll down to presets here. Flip fluid. Then drop down a fluid compress node. And then drop down a particle fluid surface. Connect the first input. And now we've got an actual mesh. And as you can see, it could be a bit higher density, so we're gonna go to here and set it to 0.01. And this might take a bit more time to render out, but it's worth it. Okay, so I don't think turning up the roughness was a good idea. So I'm gonna go I'm going to set the particle separation to 0.06. On the particle fluid surface, set it to 0.05. Okay, that's a bit slow, isn't it? Go back onto the dot now. On the flip object, set it to 0.01. Copy parameter, come on, go on to particle fluid surface and paste it onto particle separation here. And I'm gonna render this out, and this should be looking a lot better. So right now we have this, and if this is what you want, then have that, but I'd rather have it actually look a bit more similar to what I had in the thumbnail. So I'm gonna go back into the .NET and set the particle separation to 0.05 so I can actually visualize it but not wait 5 hours to actually do it. I'm gonna go into attribute VOP and I might turn down the turbulence. See what happens. I think it's going too far out here, so turn down the amplitude, do something like that maybe. Okay, that's definitely not what I want. See what happens if we turn up the turbulence. Nothing seems to change by the seems of it. Turn up the roughness. Turn up the roughness seems to speed it up, which is good. I'm gonna turn up the amplitude. Okay, this is looking more like the thumbnail, so I'm gonna dive into the .NET on the flip object, set it to 0.01, come back out, set it to the start, and just play through. And I'll let you know what we've got by speeding it up. Okay, so it's still pretty thick. Go back into the .NET on the flip object, set the particle separation to 0.04. I'm going to set this to 2. That's better better because it's faster now, which is kind of what I wanted. But you can do it however you want. You've got like the main bulk of what you need, so you just need to adjust a select few settings to get what you want, but that is pretty much the tutorial. Just as a bonus, I'm gonna come out of this, I'm gonna quickly just do a render setup, so I'm gonna speed this section up, but then I'm gonna give you the material settings you need. Okay, so once you've got your render setup done, you're going to want to drag a principled shader to the material palette, then drag that material principled shader onto the liquid. Then set the color to whatever you want. So I kind of went with like a vomit color, but you can go with whatever color you desire. Set the albedo multiplier to 0.2. Leave the IOR to 1.5, set the roughness to 0, the anistropy and anistropy direction to 1. Then on reflection, set the reflectivity to 0.75. Then scroll down to transparency and set the transparency to 0.8. Then set the dispersion to 1. And you should end up with something like this. Then go to out, go to rendering and set the pixel samples to 6 by 6. Tick on override camera resolution. Then click on use a specified resolution and set it to 1920 to 180. And that is how you create a projectile liquid simulation in Houdini. Thank you for watching. Drop a like and a subscribe and have a lovely day.